All right, part 2 of the Learning Target 8 video. We're still solving systems of equations. This is our third method to solve them. The last video, substitution, was an algebraic method. This is also an algebraic method, so we won't be using any graphing. In elimination, the goal is different than it is in substitution. In substitution, I'll remind you, the goal was to substitute one equation into the other one, leaving you with only one variable to solve. The goal with Learning Target 8 elimination is to eliminate one of the two variables by adding the two equations so that you then can solve for the variable that's left. So again, you're still trying to make it, where there's only one variable remaining in the problem to solve for. So there's our goal. So number one, it's a little bit different than the step one in the last video. Multiply one or both equations by a number so that the resulting equations will have opposite x values or opposite y values. All right, I know that's kind of confusing, but here's an example. This problem already has a negative 3y and a positive 3y, opposite y values. Same number, but opposite y values. So this example wouldn't require any multiplying to either equation. You could just add the two equations as they sit. And when you do, 4x plus 2x gives you 6x, and negative 3y plus 3y gives you 0, and it will equal negative 22 plus 16, negative 6. Then we could solve for x by dividing by 6. And then we'll finish it in another problem. But that's how you would start that process, noticing that the 3y and negative 3y would already cancel if you added those two equations. The second example, if we see an example like this where they already have a negative 5y and a negative 5y, so they have the same number in front of the y value, they're just not opposite signs, then I would choose to either multiply the top or bottom equation by negative 1.
Anthony Duffy and Kevin Smith.
Sorry about that interruption there. But I was saying we could either multiply the top equation by negative 1 or the bottom, both sides, so that what happens when you multiply negative 1 times 6x, you get negative 6x. Negative 1 times negative 5y makes positive 5y. Negative 1 times negative 8 makes positive 8. We won't change the second equation. 4x minus 5y equals negative 12. For this reason, we now have a positive 5y and a negative 5y, what we're looking for, so that if we add these two equations, the y's will cancel. So if we did add them, negative 6x plus 4x would make negative 2x, and 8 minus 12, when you added 8 plus a negative 12, you get negative 4. So negative 2x equals negative 4 divided by negative 2, and we'd get x equals 2. And we could finish it from there, but we won't. We're just still looking at the step one, because this is ultimately the problem we're going to finish. If we had a situation like this, where a and 4a, I'm looking at a and 4a, they don't have the same number or opposite signs. Now I'm looking at the b's, negative 3b and positive 2b. They don't have the same number, or well, they already have opposite signs, but not the same number. So we're going to have to do a little work for the step one. All right, so if I'm solving the example, I would multiply the top equation by negative 4, so that negative 4 times a would become negative 4a. Negative 4 times a would become negative 4a, and it would cancel with the positive 4a that's underneath it. Okay, but we got to do that to everything in the equation, both sides. All right, so the result would be negative 4 times a, negative 4a, negative 4 times negative 3b, positive 12b, and negative 4 times negative 22, positive 88. No need to multiply the second equation by anything, so I'll just copy it over here. And we'd be ready to go. So step 2 is actually the process of adding these two. We've kind of been doing step 2 already above, but we're actually going to finish this problem now in step 2. So when we add them, negative 4a plus 4a adds to make 0, so the a's are gone. They are eliminated. I probably should have used that word much earlier, but they are eliminated. That's the process of elimination there, the method of elimination. Then when we add the b's, 12b plus 2b, we get 14b. And on the right side, you get 88 plus a negative 4 makes 84. So we have 14b equals 84. Fingers crossed, when we divide by 14, we get a nice number. So got our fancy calculator here. We can pull up and 84 divided by 14. I should be able to do that in my head because it's 6. The answer, b value, 6. All right, so our step 2 is done. We've added the two equations and solved for the variable that was left. All right, which means if we're getting a number, b equals 6, then our two equations, if graphed, would have crossed at one point. So our answer, which is in alphabetical order, A, comma, B, our answer is an ordered pair, and 6 is the value for B. So we've got one of the numbers. Step 3 is the same step 3 it was in substitution. Substitute the value from step 2, so take your b equals 6 and plug it into either original equation and solve for the other variable, which in this case would be solve for a. So the first equation was a minus 3b. So a minus 3b equals negative 22. If we plug in b value 6, it will say this, a minus 3 times 6. So a minus 18 equals negative 22. Solve for a, add your 18. When you add 18 to the equate to both sides, we get negative 4. So our answer has a value negative 4. Our final answer, negative 4 comma 6. But again, like the last video, I still want to prove to you that it works in both. If you had chosen to plug this b value 6 into the other equation, 4a plus 2b equals negative 4. I just want to prove, negative 4. I just want to prove that if you had chosen to plug that b value 6 into this equation, you still would have gotten the same a value negative 4. So let's see how that works out. 4a plus 2 times 6, so 4a plus 12 equals negative 4. Solve for a, so subtract 12. 4a equals negative 16, divide by 4 to both sides, and a equals negative 4. So either way, we would have gotten a value negative 4. So our final answer, one solution, the point negative 4 comma 6. And that's elimination. And again in class, we had 12 problems. You're welcome to try any of these at home and then come in, and I've got the answer key. But we looked at some of these to get started. Just for the sake of the video, looking at number 1, the y values are opposite signs already, so they're ready to just add them, and they cancel, and you get 5x on the left side, 2x plus 3x equals 15, so x is 3. Then plug it back in and figure out what y value is. But for an example like, let's see, number 10. The step 1 is a little more difficult because you have to multiply the top equation by something and the bottom equation by something so that they have opposing or opposite numbers in front of the variable. So I'm going to focus on the 5 and 7. It's kind of like finding a common denominator or common multiple. 35 is what I could make 5 and 7 into. I could multiply 5x times 7 to make 35, or the bottom 7x times 5 to make 35. But when I'm looking at the 4 and the 6, I see something a little better. 4 can become 12, and 6 can become 12 if I multiply. So the step 1 in number 10 would be multiply the top equation. I'm going to go with 12. Multiply the top equation times 3 to make 3 times 5x, 15x, 3 times 4 plus 12y, and 3 times 12, 36. Forcing me to multiply the bottom equation times to make a 12y in the middle, but I also want it to be negative. I'm going to have to multiply by 2 in the second equation because there's already a negative in front of that y. So 2 times the 7x would make 14x, 2 times the negative 6 would make negative 12y, and 2 times the 40 would make 80. And that would be your step 1 because now when you add these two, the y's cancel. So we won't finish it, but anyways, that's kind of one of the difficulties students tend to have is coming up with that step 1. So that's learning target 8, elimination.